Hello everyone. Welcome back to the second part of our two-part series in volumes in Kubernetes. So I am back to shooting the video or to recording the video after a short break. Before that, I was recording the part one of this video, which went quite lengthy. So I decided we can create a two-part series out of it. Let's get started now. So where we left in the last part was host paths, right? So now we have to use host path volumes. We have used host path in our persistent volume before this, but it was a persistent volume. Right now, what we are going to do is we are going to create a normal volume which uses host path. So as you can guess, the volume will be tied to the pod then. So if the pod dies, volume also dies. But if the container restarts, then the volume will be there. Now you would be asking yourself or thinking that that's what we did with the persistent volume, right? So even when we created persistent volume, we used host path there so that we can tie our persistent volume to a particular directory in our file system, right? That's what we did. So how is persistent volume different than host path? Actually, that's what we did. But like I told you, we usually use a different storage for persistent volume, which we did not do, but we usually do that by the help of storage class. But right now we did not do that. So right now, even with the persistent volume, we tried to use host path. So now when we will create the host path also, you will see it is very similar to the persistent volume. The only difference being there we created a persistent volume separately as a Kubernetes object. Then we created a persistent volume claim as a Kubernetes object. So that's the only difference. Otherwise, the everything else remains the same. That host path volume will remain even if the pod dies, and multiple pods can access that host path. So it will remain the same, but few things will not be there, like the access modes. And one very important thing we forgot to talk about was the reclaim policies. And actually, we could have tried out these reclaim policies, but the cluster went down actually, because killer coda only allows us to have use the cluster for 1 hour. So maybe this is the right time to talk about the reclaim policies. Let me search for that. Yeah, so these are the reclaim policies. So what is delete policy basically? So delete policy, it says for volumes plugin that support for delete reclaim policy. Is it called delete reclaim policy? Obviously, because it is reclaim policy. Okay, so I got a bit confused here. Sorry for that. Yes, so these are reclaim policies, right? So it would have three types. Obviously, I was confused about reclaim and recycle. So I thought this is delete recycle policy, which sounded odd. Okay, so delete reclaim policy, what it does is, for that I need a diagram. So we will do some changes in this diagram only. Let me get a pen. Uh, can I make it bigger? I cannot. Let me make this smaller then. Now, how is it? Yes, it is fine. So now what happens with delete reclaim policy? See, what delete reclaim policy does, when the PVC, the persistent volume claim, is deleted, then what the delete policy does is that it will remove the persistent volume claim, and it will also remain the delete the persistent volume also. So everything gets deleted. So for example, this was 100. Let me use text. Oh no, what did I do? This is difficult. Yes. So for example, this was 100 GI. Okay. So if this was 100 GI, what happens with delete policy is, if this is deleted, see, if the reclaim, if the pen, if the reclaim PVC is deleted, if the persistent volume claim is deleted, then the data in the PV is deleted, as well as the PV or the storage itself removed. So the persistent volume and the storage that was associated to that volume, be it a cloud disk, be it like from some other storage, then it will also be removed. So now what happens is, for example, this was 100 GI. Now it will be left with minus 10 GI. So now it will be left with 90 GI. So what delete policy is doing is, it is removing the persistent volume storage also. So it is also deleting that particular storage that is associated with it. When will it do that? Whenever the PVC is removed. Let me formally read the definition as well. It says, for volume plugins that support delete reclaim policy, deletion removes both the persistent volume object from the Kubernetes as well as the associated storage asset. Right? Now you would understand this, that even the storage is removed from here. So the storage itself is removed from 100 and it is made 90, for example. Right? So even in the external infrastructure, the storage is being removed. That is what delete does. Next is recycle. Where is reclaim? Reclaim was the first one. Where is reclaim? Retain, sorry, retain. I'm confusing retain with reclaim. Sorry for that. We should have started out with retain. Let's now talk about retain. So what happens with retain? This was delete reclaim policy. And give me some time so that I can, okay, sorry for that. Remove this. I'll copy this because we want it here as well, and delete all this stuff. Fine. Let's take it somewhere else. This was delete reclaim policy. Let's copy. Okay. Now we will talk about, why did it not copy? Retain reclaim policy. Now what retain reclaim policy will do is that it will give me the pen again. Yes, fine. So what will happen is, when the reclaim policy, oh no, it will be erased. So what will happen is, when the PVC is removed, then the data is not deleted and the persistent volume is also not deleted. So even if the persistent claim is removed, still it will be useful. So whenever you will create the same persistent volume claim again, you will be able to see that particular data again, and we will be able to use that particular persistent volume as well. That's what reclaim policy does. Retain reclaim policy does. Okay, so now let's move to the third one. So I hope you understood the retain reclaim policy. What happens is, even if the claim died, okay, even if the claim died, the data and the PV still remains. So when you create the claim again, then you'll be able to access the same data again. Let's move to the third one. I'll create the cross again. I like doing that. I'll not remove that. And the third one was called retain is done, recycle is left. Let me also read the retain definition for you. So retain reclaim policy allows for manual reclamation of the resource. Like I said, we can reclaim that resource because the data is not deleted and the resource is also not deleted. When the persistent volume claim is deleted, the persistent volume still exists and the volume is considered release. It is important. So the volume is considered release, and then you can manually attach like that volume, or you can delete it so that you can reuse the data in that volume. Like it says, when the persistent volume claim is deleted, the persistent volume still exists and the volume is considered released, but it is not yet available for another claim because the previous claim data remains on the volume, right? What it is saying is, see, it said that it is not available for another claim because previous claims data remains in the volume. See, if we create another claim here, if we create another claim here, it cannot access this. Only this claim can access this. Only this claim can access this, which is deleted. So when we create this claim again, right? When we create this claim again, it will be able to access it again because the data and the PV is not deleted. So we deleted the claim, data and PV were not deleted. Whenever we recreate the claim, we can not only access the data, we can also change the data, as in we can read the data as well and we can change the data as well. But if we create another claim, different claim, it will not be able to use this particular volume, right? So for this claim, we will only have 90 GI, but for this claim, it can use this data. So this claim will not be able to use this data because this already has data for this claim created by this claim, right? So that's what it's saying, that because the previous claimant's data remains on the volume. And then there is all that I said, that you can delete it and reuse it, etc. So this was retain, delete, and now let's come to recycle. And it says that recycle reclaim policy has been deprecated. So rather, you can the recommended approach would be dynamic provisioning, but I think I should explain you this. So what basically happens with recycle is, let's go back. Okay, so I was making all the changes in retain. Again, a mistake. Sorry for that. Let's call it retain. Anyways, I'm not providing these as notes, right? So I can do anything, but it just does not look good. That's why I'm doing it. Recycle. Now with recycle, what happens is, even if the PVC is deleted, then what happens is the data is also deleted. If the PVC is deleted, the data is deleted. Okay. Data. Wow. 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 Let's bring that up again. Remove this. So what I am saying is that even if the PVC is deleted, data. So when the PVC is deleted, the data is also deleted, but the PV remains, right? The storage remains. So if the PVC is deleted, Kubernetes automatically cleans that data and then it will be available for other persistent volumes, persistent volume claims, sorry. So this time we can access this, right? We couldn't access this using a different volume claim. We can access this using a different volume claim. Why? Because as soon as the PVC is deleted, data associated to that PVC is also deleted, and then this is not marked as released. If you remember, in the retain policy, then the volume is marked as released here, right? But here the volume is marked as not released but available because the data has been removed. So now there is no association between this claim and the PV. So now any PV can access this. So for this PV, for this PVC, the PV it can access would be 100 GI again because it can also access this one. So that is what retain reclaim policy is. That is what all these reclaim policies are. I think I've spent a lot of time now here. So we should quickly move to the different things. Access mode done, reclaim policy done. This is also done. Talked about all this, talked about this as well. Now let's go to host path before our new cluster is also deleted. Look, okay, there's a chance that this cluster will also be deleted really soon. So let me restart another one. So give it some time before it is created. So it is started again. And now we will try to find out in the volume section host path. Yes, perfect. Host path. Give us some example. Great, we have example as well. Great, that's great. Let's copy it. Uh, volumes and then volumes. Then we can use host path on our own. Yeah. So what we will do is we will create this file called host.yaml. Let me paste everything here. Now you'll find it very similar to the emptyDir because we are doing everything in the same pod and we are just going to use in the volume section in emptyDir. You would remember we were using emptyDir here. The only difference is we will use a host path here. So host path will have this path and we can keep the path as anything. So let's call it war. That's it. Let's call it data. That's it. And we can delete a few things. We don't need OS selector. Also remove this. Let's create a better name for the pod. Let's call it Nginx. Let's call it Nginx as well. Image would be Nginx again. Mount path, that is important. So you would know what is the staple directory that we use: user slash share slash nginx slash html. Name is example volume. Let us remain the same. Read only. Let us remove that. Read only. And in the volumes, you will see we have this name. So the name of the volume and the name in the volume mount should be the same. And then we have this host path, which is path and data. So this is fine. And then type is return directory. So this is optional. Let us not do that. And I think this is good to go. Let's apply this. Not this. Okay, get pods. Give it some time for the container to create. So yes, it is running. Now let us not waste time directly. No, let's not exec. First, let's describe it so that we can see pod nginx, so that we can see the like the mount path and the volume, etc. So this is our nginx pod. And if we try to find the mounts, we can see that this is for service account, leave that. But this one, user slash share slash nginx slash html, is where our volume called example volume has been mounted. And if you see the volumes, we have this one volume which is called example volume, and it is type host path, and it is at data. Yes. So now what we will do is we will go and do quickly exec. Let me also do ls. If I can see the, is it present in here? I'm trying to find the data folder, but like earlier, I couldn't find it again. Okay. Let's exec now. Exec into the Nginx pod using bash. Now what we will do is we'll quickly go inside the folder which we were using, user slash share slash nginx slash html. We do not have anything here. Let's echo 1234 again inside something called home.html. And we can do ls. We have it here and we can exit. Now, in the earlier version, what was happening? If we delete the container, then, or if we not delete the container, if we restart the container, then the emptyDir would make sure that the data is safe, right? The data is persistent, just for just at the pod level. So if the container is deleted, data still remains. Host path is exactly the same, but only difference is if the pod dies also, even if the pod restarts, the data will remain the same. So that's what we will do. We did not try that thing with emptyDir also, but you could have tried that out. If you delete the pod, if you restarted the container, the data was still there. But if you would have deleted the pod, the data would not have been there. So you can try that with the emptyDir as well. But for now, let's delete this pod. It has been deleted, and we will create it again using the command. It was called host.yaml, and it will take some time to create. It has been created. Let us do kexec. And now if we go to that particular directory, which is user/share/nginx/html, you will see the home.html here. If I do ls, if I do cat into the home, you will see we have this 1, 2, 3, 4, right? So that is what this host path does. Host path is doing nothing, but it is mounting this directory into the pod from the control plane, from this VM actually, which is control plane. So maybe you can do one task here. You can try finding the data folder where it is present in the local directory. I think it should be in root then, right? Uh, where is data? So this should be somewhere. I cannot find it right now, but you can do that experiment. You can try figuring that out on your own. But that is the basic crux of host path, quite similar to persistent volume. You would be feeling like that. The pod deletes, the pod gets restarted, but the volume still is persistent. That's what host path is. Finally, we can move on to the config map and secrets. So how we will work with config maps is, you know how to create config map. I would assume that, because if not, you can watch my video about config maps and secrets. It is very simple. So I'll call it c.yaml. We will do this quickly. Okay. Let's go and find some config map. You can also create this using using that command, kubectl create command. Here is a config map till data. Let's copy it, and data we can keep anything. It's called game demo. Let's call it game only. Data. Let's create a file a.txt. 1, 2, 3, 4 only. Yes, good to go. So now we will apply this. Now we are going to use this particular config map in our pod. We already have one pod, Nginx. Let's create a similar pod. Let me vim into the Nginx pod. What was it called? Host path, right? Let me copy that. We will need this. Let me create this one called pod.yaml. So we have to change the name. Let's call it 2. I write these very weird names because it is much more easier for me to type them out. So you can choose your names in a better way. We'll still have the same mount path. We'll still have the same name. And we can also have the same name for the volume mount. We can have the same name for the volume as well, because we are going to mount the config map as a volume. But the volume name, you can keep anything. But the config map name, we will keep, we will write it here. So that should be different. Like, for example, we will not have the host path, right? We'll remove host path. And now we will write this config map. And what is the command? Is it like name? Because we have name here. Let's check that out. Let us search for the volumes again. Types of volumes, config map. So in the volume section, we have this name which should match this name, and then config map has a name. Fine. Config map has a name in this format. Okay. So now we can have a name. Name of the config map was game. And I think this looks fine. I hope you were able to understand what's happening. So this is the mount path. Basically, this is where the data of that config map will be going to. And then we have named the volume, which is example volume. We have named it here, but we are using it here so that this volume is mounted to this path. And then in the volume section, we are actually having this name, but the volume is actually a config map, and the config map has been created, which is called game. So we are referring it from here. Yes. Apply this pod.yaml as well. Kubectl get pods. It will take some time in running. It has been running now. It is running now. Let's do exec into the pod called 2 using bash. And now if we go to that same directory, user slash share slash nginx slash html, you will see our a.txt to be there. And in that a.txt, you will find the data, which was 1, 2, 3, 4. So that is how it works. That is how we can mount the volumes with, that is how we can mount our config maps and secrets into our pod using volumes. And this is the actual way of using it in a production ready cluster, on a production level cluster. So even when we created these volumes, when we created these config maps and secrets in that particular video, in my config map and secrets video, I talked about the right way of doing it is using volume mounts, right? Using mounting it as a volume. So that's how we do it. I think I have covered everything now. One thing that is left is the dynamic provisioning part. So for that, we need to know about storage classes. We will not do the hands-on about storage classes. Why? Because we would need the storage services from AWS, from these cloud providers. So that will be a different topic itself. So that is not a very big topic actually. You can learn that on your own. But if you want to, storage, okay, storage class, but it is very similar to what we have already done. So it is very small concept. So with storage class, what we can do is, like, you can provide this provisioner here with the storage class, and then you can basically create a persistent volume claim. Have we created it here? No, but we can create this persistent volume claim that uses this storage class. So like when the persistent volume claim is created, and if there is a PV like for that, then it is fine. But if it does not have a PV, then what Kubernetes would do is it would automatically provision this PV according to the specification of PVC, depending upon the storage class. So storage class is nothing. Where is storage class? So you can see it will define how the storage should be provisioned. After that, the process remains the same. You will create a storage class, and then you will create a PV, and you will create a PVC. What is dynamic provisioning? So dynamic provisioning is this concept only, where the PV is automatically created when the PVC is made. So we do not have to make the PV manually. How this works? This works like, first we create a storage class. In the storage class, we define how the storage should be provisioned. Then we create this PVC that uses the storage class. And once this PVC is created, then the PV is automatically provisioned. Like for PVC, if the amount it requires is like 500 MI. So a PV of 500 MI will automatically be created using the storage class. So if you want to read more about the provisioner and all, you can find that here. If you want to use a storage class, then you can read this document, which is, you just have to search for storage class and you will come here. So I think we have covered everything about Kubernetes volumes. These were the 4 types of Kubernetes volumes that are really important. We covered all of them. We also looked into this storage class and dynamic provisioning. So this was a very in-depth tutorial. It was a very lengthy tutorial. That's why we have to divide it into 2 parts. So I hope you were able to understand everything. I hope you watched both the videos and it was helpful to you. If you want to watch more content on Kubernetes, there is a lot of content on this channel, so you can check that out. In either case, thank you for watching this one, and I'll see you in the next one.